Okay, so in this section, we're just going to talk about referring to a table of integrals to find an antiderivative of something that's maybe a bit more complicated. And it sounds like it might just be a plug and chug, like I'll give you a formula, you plug and chug, but it's actually a little bit more complicated than that. For the most part, if you're given a table of integrals, you might have to manipulate your integrand or your integral question to get it to match something on that table. That's going to be a big part of this section. So we just have a few examples to cover. So we're just going to jump right into this first one. Use this given formula, which is straight from a long list of a table of a whole bunch of antiderivatives. This is just straight from there to find this antiderivative. So let's first practice by just simply comparing. So I'm going to look at the formula as well as the question. And you can see how they're almost identical, except for the formula has a 1 in front of the x, and my question has a 3 in front of the x. So you just factor out that 3. So then this guy actually becomes 3 times the integral of x over 4x plus 6. And then when you do a comparison to your formula, to your question, you want to identify all of the unknowns. So a and b in this case. So in our example, a is 4 and b is 6. I highly recommend you write that down because it seems simple, but I promise it's going to get complicated. So a is 4 and b is 6, and then I can use the formula. So I still have a 3 on the outside of the integral, so it should be on the outside of the parentheses. And then I have an x over a minus b over a squared times ln of ax plus b plus c. I truly just literally copied it down. Now I can plug in all of my a's and b's, and so I will have 3 times x over 4 minus 6 over 4 squared times ln of 4x plus 6. And then, of course, plus c, and we should definitely distribute and simplify. So 3/4 x minus, this would become 18 over 16, which of course could reduce, and we definitely should always reduce our fractions anytime we can. So 9 over 8 ln of 4x plus 6 plus a constant, ta-da. Okay, not so bad. Let's talk about what happens when it gets a little bit trickier. So very similar question, but a little bit more of the manipulation is going to be required. So this one is use this formula, which is straight from a table of integrals, to find this integral. Now the problem is this integral has an x to the 4th, but my table of integrals has a x squared or u squared. They just use a different variable. So we have to manipulate what we have. So you're going to probably have to do some manipulation. This one's a little bit straightforward if I rewrite it. I'm going to rewrite this as 4 plus x to the 4th. Now, I certainly didn't have to change that order. I just thought it looked a little smoother. And instead of an x to the 4th, I'm going to write that as an x squared squared, because then you can see the u sub. So I should let my u be the x squared, and the du would take care of that entire numerator completely. So then this integral becomes the integral of 1 over the square root of 4 plus u squared du, which is exactly what I have. And then I have to identify this is an a squared, but I have a 4, which means your a squared is 4. That's pretty important. A squared is 4, which really means my a is 2. So we just have to be really careful to identify your a's, b's, possibly c's. And then I can just have the answer. So it's ln of u plus the square root of a squared plus u squared plus c, and then I plug and chug. So ln of u, which is x squared, plus a squared, which is 4, plus, because a was 2, that's another important thing there, plus u squared, which was x squared squared, which of course turns into x to the 4th, plus c, ta-da. Okay, not so bad. Now let's make it a little bit more. So very similar, manipulate what you have until you get what you want. So now I'm going to give you a whole table. So 3 different formulas from a table of integrals, and you have to decide which one to use. Not only which one to use, but let's actually go through and solve this integral. So this one's definitely a trickier problem. So I'm going to take that problem and I'm going to rewrite it down here. I have the integral of, I'm going to rewrite this as 2x times x to the fourth dx over the square root of 7 plus 3x squared. And then you should be able to see that that x to the fourth is actually x squared squared. And then you might be able to identify that u sub. So I'm going to let u be x squared, because du is 2x dx, and then this 2x dx matches perfectly, so it can turn into a du. So then this will become the integral of u squared over the square root of 7 plus 3u. And then you can look at this and then try to compare it to one of the three formulas on the table of integrals. And we can identify just by looking through each one of those that it looks like that middle one is going to be the ticket. So for us, our A was 7 and our B was 3. When I compared each of these, so then I have an answer and I can just copy it down. So I'm going to copy it down. This is going to be 2 over 15b cubed, 3b squared u squared minus 4abu plus 8a squared times the square root of a plus bu plus c, and then I have to plug and chug. So now is when I finally get to plug and chug. It takes a little bit of work to get to the point that you can just plug stuff into a formula. So this section, it might seem like all you're doing is plugging stuff into a formula, but you have to get to the point that you can do that. So it actually is a little bit harder. So the homework will take a little bit of practice and probably take a little bit of time. So here we have it, 2 over 15 times 3 cubed. I don't know if I wrote that down correctly. I did. Okay. And then times 3 times 3 squared u squared minus 4 times 7 times 3 times u plus 8 times 7 squared, the square root of 7 plus 3u plus c, and then you have to replace your u. I'm going to get out my calculator and simplify this. 15 times 3 to the power of 3 is 2 over 405. And then I have 27 u squared. The 27 came from right there, but u was x squared. So that's actually an x squared squared, which of course is just x to the power of 4, minus 4 times 7 times 3 is 84u, plus 8 times 7 squared, which is 392, times the square root of 7 plus 3u, but again, u was x squared. Ta-da! So a big chunk of this section, that's all there is to 3.5. It's a short section, but a big chunk of it is manipulate what you have in the question to get it to look like one of the formulas that you're going to be given. So take your time with this one. It might take some practice. You might have to write multiple tries down before you can get it to match perfectly. All right, that's all there is for 3.5.